communication between the brain and the new body. The machine utilizes microsurgery techniques and delicate microscopic adjustments to ensure the proper alignment and fusion of the spinal cord and other tissues. To help reconnect the severed neurons, BrainBridge uses a proprietary chemical adhesive, polyethylene glycol, which is applied locally to the spine at the point of fusion. Once the spinal cord is connected, a specialized implant is placed in the epidural space behind the spine over the point of fusion. This implant promotes the repair of damaged neurons and allows the patient's brain to form neural connections with the new body and ensures that the sensory system is restored. It also functions as a temporary backup control device for the donor body. The next step of the operation is a face and scalp transplant where all the muscles, soft tissues, and skin are removed from the recipient's face. The donor's face, muscles, and soft tissues are then precisely transplanted in their place. By transplanting younger donor tissues, the procedure reduces the probability of tissue rejection and offers potential for aesthetic enhancement, particularly in cases where the donor is significantly younger than the recipient. It also restores functionality and structural integrity to the recipient's face and rejuvenates its appearance. BrainBridge then carefully sutures the skin to conceal the complex rewiring beneath the surface. The skin is then treated with a special spray that contains growth factors, antifibrotics, and antibiotics. This spray promotes faster skin healing, prevents infections, and reduces scarring in the sutured area. Finally, immunosuppressive drugs are administered to prevent the recipient's immune system from rejecting the donor body. After the surgery, the recipient is carefully monitored in an intensive care unit and is kept in a coma for up to 4 weeks to prevent movement or misalignment of the connected body parts. During this time, the head, neck, and spine are firmly stabilized to optimize the fusion of the spinal cord. Life support systems are utilized to regulate breathing and circulation, while nutrition is delivered through a jejunostomy feeding tube. Gradually, the recipient's brain should regain control over the new body. As the recovery process advances and the patient regains mobility, there will be a need for extensive rehabilitation, physical therapy, and psychological support to help the recipient adapt to their new body and regain motor functions. BrainBridge Headband, which is equipped with a brain-computer interface, will allow the patient to communicate their needs during recovery. Thanks to the power of thought, the headband decodes brainwaves and turns them into text or speech. It could allow the patient to control other devices directly from their brain, granting them the autonomy to execute specific tasks independently throughout their recovery journey. Because of the complexity and unexpected challenges of the head transplant procedure, self-learning algorithms allow BrainBridge to avoid errors and adapt surgical plans in real time.